Welcome to the Explainer. Today we're going on a journey. We're going to transform the way you see the sky, changing it from just empty blue space into a living, breathing landscape that you can actually read like a map. Yeah, we're going to see the world through a pilot's eyes.
And that right there, that's the core idea. We're going to learn how a pilot sees all the invisible forces that shape a day of flying, and it all starts with the very first check they make in the morning.
So, where do you think a pilot's day really begins? It's not at the airfield, not in the cockpit. Nope. It starts with a pressure map. Why? Because pressure, that is the fundamental engine that drives all the wind on the planet.
It all comes down to one simple rule of physics. Air always moves from high pressure to low pressure. So, a high pressure system means you've got sinking, stable air, and usually beautiful clear skies. That's great for flying. Low pressure, on the other hand, means air is rising, and when air rises, it forms clouds and creates potential instability. This is the very first clue a pilot gets about what the day has in store.
Okay, but what's really cool is how you can actually see the wind speed on these maps. These lines here are called isobars. Now, if they're packed really tightly together, that means a sharp, steep change in pressure, and you're going to have some very high winds. But if they're spread far apart, well, that signals a much gentler gradient, and that means light, flyable winds. For a pilot, seeing those widely spaced lines is a big green light. All right, so with that big picture view of the wind, our pilot heads out to the launch site. And here, the focus shifts to a totally different kind of power source, a sort of hidden fuel that's going to determine how high they can climb. And that fuel? It's humidity. You know, humidity isn't just about feeling sticky. It is a critical performance factor in flight. For one thing, moist air is actually less dense. It's thinner, which changes how the wing performs. But way more important is that it contains this hidden energy. When water vapor, which is invisible, condenses and turns into a visible cloud droplet, it releases a little burst of heat. Scientists call it latent heat, but for a pilot, it's basically rocket fuel for those rising columns of air we call thermals, kicking them into a higher gear. So the crucial thing to understand here is how quickly that rising air cools down as it goes up. And that speed depends completely on how much moisture is in it. This cooling rate has a technical name, the lapse rate. And as you're about to see, the difference between the rate for dry air and moist air is, well, it's dramatic. And this just illustrates the power of that hidden fuel perfectly. Look at that. A parcel of dry air cools down really fast, about 5.4 degrees Fahrenheit for every 1,000 feet it climbs. But moist air, because it's releasing all that latent heat energy, cools down almost twice as slowly. And what does that mean? It means it stays warmer than the air around it for much longer, allowing it to climb higher and form way more powerful clouds. Okay, so our pilot is finally in the air. Now, you can't see pressure, right? And you can't really see humidity. So you have to rely on the sky's own signposts. And those signposts are the clouds.
First up, let's talk about the pilot's absolute best friend, the fair weather cumulus cloud.
These things are basically bullseyes in the sky. See those distinct flat bottoms? That's not a coincidence. That flat line shows you the exact altitude where rising columns of warm air, thermals, have finally cooled enough to hit their dew point. That's the point where invisible water vapor becomes a visible cloud. For a pilot, that flat bottom is a target, a giant sign that says, hey, the elevator of rising air is right here. But, you know, even your best friend can have a bad day. When these cute, harmless-looking clouds start growing, and I mean really growing upwards, that's a huge warning sign. Yeah, when those friendly little cotton balls start looking more like towering cauliflower, they've turned into cumulus congestus. This is a sign of way too much energy. The lift is now dangerously strong, and pilots know to stay far, far away to avoid something called cloud suck, which is exactly what it sounds like, getting pulled uncontrollably up and into the cloud. Not good. All right, now for a cloud that tells a pilot not to even think about taking off. This one basically screams, stay on the ground. If you ever see these beautiful, eerie UFO-shaped clouds just hanging over the mountains, the decision is simple. It is not a flying day. These are lenticular clouds. They look calm and stationary, but they're a sign of incredibly high winds flowing over the mountains, creating violent, invisible turbulence called rotor down below. They're gorgeous to look at, but they are a clear signal to stay put. And finally, let's look at the messengers of the sky, the clouds that tell the future, forecasting what's coming hours from now. These really high, wispy clouds are called cirrus. They're made of tiny ice crystals, and they're often the very first sign that a big weather system is on its way.
So seeing these tells our pilot, okay, the day might be good now, but the weather is about to change. They can expect stronger winds and different conditions probably in the next 6 to 12 hours.
All right, the day is winding down, the sun's getting lower on the horizon, and the whole energy of the atmosphere begins to shift. Our pilot is now getting ready for the final and often most beautiful phase of the flight.
See, all day long, our pilot was hunting for unstable air, those warm parcels that just want to rise. But as the sun sets, the ground stops heating and starts to cool. The air follows suit and becomes stable. And this creates these incredibly smooth, predictable conditions that pilots call glass off. It's perfect for a gentle, serene landing.
A key feature of this evening stability is something called a temperature inversion. Now, this sounds a little weird, but it's really common. It's just a layer in the atmosphere where for a little while, the air actually gets warmer as you go up instead of colder.
Think of this inversion as the literal lid on the sky. The thermals that were rising and bubbling up all day simply can't break through it. It just caps them off. This stops all the turbulence and creates those exceptionally smooth conditions for that perfect end-of-day flight. It also traps haze and dust underneath it, which, by the way, is why you get such dramatic, colorful sunsets on those evenings.
So let's do a super quick recap of the whole journey. We started the day with our morning briefing, and we said the most important sign for a good flight was a high-pressure system. What did that mean again?
That's right. Sinking, stable air. That provides the calm foundation for a great day of flying. And from there, we learned how to spot the hidden fuel in humidity and read the clouds as signposts, all the way to that smooth, glass-off landing in the evening.
By understanding these fundamentals, pressure, humidity, stability, and clouds, the sky stops being this big mystery. It starts speaking a language of safety, a language of energy, a language of flight. The real question is, are you listening?